Hello, my name is Bernadetta Bellarida. I work in the Department for the Control of Neglected Tropical Diseases here at the World Health Organization, and I'm responsible for the neglected zoonotic diseases. We are preparing a toolbox to assist countries and stakeholders in the task to control and eliminate some of these neglected zoonotic diseases. This presentation is part of the toolbox and covers Taenia solium, the cause of neurocystic psychosis and a major cause of epilepsy in endemic countries. Despite the burden cystic psychosis imposes on the affected communities, there are very few programs to control Taenia solium. Our objective is to facilitate the implementation of such programs. The starting point for a control program is, of course, gaining a baseline to identify the affected areas. So with this in mind, we have created the mapping protocol for the identification of endemic and high-risk areas for T. solium. We are delighted you have joined. Should you have any comments or suggestions, please let us know. Our contact details will be at the end of this presentation or in the companion document. Thanks for your interest. I hope you'll enjoy the rest of your presentation that will be led by Mary Shell. Thank you.
Welcome all. My name is Merichel Donadeu and I'm going to guide you through this video on the mapping of Taenia solium. I hope you find it useful. This mapping tool comprises of three companion elements. The first one is a document with the detailed mapping protocol and basically other notes of this video. The second is an Excel document and it's the risk classification tool. And this is a tool that you will be able to use to assess your own areas of interest. And then is this video presentation that it's a more detailed explanation to guide you step by step on the mapping protocol and on the use of the risk classification tool. To start a Taenia solium control program, first we need to identify the endemic areas, so we know in which areas we need to work and which areas we need to prioritize. And what does it mean, endemic area? Endemic means that there is the presence of the full life cycle of the parasite, so there is active transmission. If the endemic areas are not known, then we can start by identifying first the areas with the presence of the disease, of any of the diseases caused by Taenia solium, and second, the high-risk areas based on the key risk factors. Mapping involves actively searching and gathering as much information as possible that can indicate or suggest that the disease is being actively transmitted in that specific area. For example, looking at this picture, we can already see some clues that might suggest that the disease is actively transmitted there. Often, the information available to us is incomplete. So mapping is really like putting together the different pieces of a jigsaw puzzle to build a picture. So the more pieces of information that are available and can be put together, a better picture will be obtained. We know that there is very limited information on Taenia solium. Wherever country or region you are, it's very likely that the information is scarce. Therefore, this mapping protocol has been developed to provide guidance, keeping in mind those limitations and trying to keep the process as simple as possible. We are going to talk about 4 mapping steps. The first one is collecting the information. The second is organizing that information. The third one is classifying the areas by risk. And the last step is confirming the endemicity. The steps 1 to 3 can be conducted by a desk review collecting as much information as possible, and they can conclude with a preliminary map. Taenia solium is a very focal disease, so it might be necessary to begin the exercise at a certain administrative level, for example at the district level, and then repeated within that administrative level, for example at subdistrict or at municipality level. Irrespective of the administrative unit, being a province, district, subdistrict, municipality, etc. The mapping process and the steps are always the same. So let's start now with the first step, that is collecting the information. When we are collecting the information, we are looking for two types of information. One is about the diseases produced by Taenia solium, and the other is about the key risk factors. Starting with the diseases, let's look first at teniasis. Teniasis is the presence of the adult tapeworm in the intestine of a person, and it is acquired by eating raw or undercooked infected pork. People with teniasis usually do not show major clinical signs, or they show only mild and non-specific digestive signs such as abdominal pain, diarrhea, or constipation. The diagnostic of teniasis can be done using techniques such as microscopy, for example, the cat that many of you will be familiar with, but there are also some techniques that could be used, like the coproantigen or molecular techniques, but they are not widely available. One thing to keep in mind is the specificity of these techniques, but we are going to talk about these later. Here you can see in this picture an egg of Taenia solium under the microscope. When a person with an adult tapeworm defecates, then they release tapeworm eggs in the feces. When the pigs ingest those tapeworm eggs that are in feces or contaminating the environment, then they develop the second disease that we're going to talk produced by Taenia solium, that is porcine cysticercosis, and that is the larval stage of the parasite. Pigs with porcine cysticercosis do not show any major clinical signs, and they usually look perfectly healthy. The diagnostic can be done by tongue inspection, that is, looking for cysts under the tongue of the animal, as shown by the blue arrow, and the animals with high burden of parasite, the cyst will be visible. Other options for diagnostic are the meat inspection, and for research purposes, it can also be used necropsy and carcass dissection. Other techniques, such as serology, they tend to have issues with specificity. Once the infected pig is slaughtered, the cyst will be present in the meat. And when that meat is eaten raw or not properly cooked, then those cysts will develop into a tapeworm. Here in the picture, you can see a piece of pork with a cyst. A cyst looks like a small bladder full of liquid, and inside there's a white spot. That white spot is the scolex that will become the head of a future tapeworm. When there are a small number of cysts, they can be difficult to see in the meat, but exceptionally there are large number of cysts, and then they can be easily seen, as we can appreciate in this picture. So this is the active transmission cycle of the parasite. So we have people with the adult tapeworm that will release eggs into the environment. The pigs will get infected by eating those eggs. Then they will have cysts in their meat. And then people eating that infected meat will develop the tapeworm. So this is the active transmission, and that's what needs to happen for the disease to be perpetuated or to be continually present in the area. We need people with teniasis and pigs with porcine cysticercosis. Let's talk now about the third disease caused by Taenia solium that is the most important from the medical and clinical point of view, and that is human cysticercosis. In this case, the people are infected not by eating infected pork, but when people eat the eggs of the parasite. That can be via the fecal oral route, because someone with a tapeworm didn't wash their hands after going to the toilet and then prepare a salad for the family. Or can be because someone ingested some vegetables that were contaminated with the parasite eggs. In this case, the person then develops the larval stage of the parasites, develop the cyst, and the cysts tend to be in the central nervous system, and that is called neurocysticercosis. Neurocysticercosis is usually expressed by seizures and epilepsy and can take years to show the clinical signs. Usually we're talking between 2 to 7 years, but can be even more. The diagnostic is done by imaging and serology. Here in this picture, we can see the brain of a 12-year-old girl that died of neurocysticercosis. And as we can see, there are plenty of cysts in the brain. So neurocysticercosis is the most important disease caused by Taenia solium and is the reason why we want to control this parasite. However, the people with neurocysticercosis do not play an active role in the transmission of the disease, as their infected tissues would not be consumed by other people to cause teniasis. So people with neurocysticercosis are a dead end and cannot transmit the disease. Also remember that it can take several years for people with neurocysticercosis to show clinical signs. This is something that is very important to remember and to take into account when mapping. Only Taenia solium causes neurocysticercosis, and it is of public health importance. Other species of human tinea, such as Taenia saginata or Taenia sciatica, they do not cause neurocysticercosis, and therefore they do not justify the implementation of a public health program. So now we have seen the three diseases that we are interested when mapping Taenia and solium: human teniasis, human neurocysticercosis, and pig cysticercosis. However, we need to remember that only teniasis and porcine cysticercosis indicate that there is an active transmission of the disease. Now, let's talk about the key risk factors for the transmission of Taenia solium. Looking at the cycle, it's obvious that we need backyard free roaming pigs. If there are no pigs, there's no transmission cycle. And we also need deficient basic sanitation. Both of them are necessary conditions for the presence of the active cycle. Both risk factors need to be present simultaneously to have active transmission of the parasite. If there are not free roaming pigs, even if there is deficient sanitation and the parasite eggs are present in the environment, the pigs won't be able to complete the cycle, so there won't be transmission of the parasite. If there is a good sanitation, that means that there will not be parasite eggs in the environment. So even if there are free roaming pigs, those pigs will not get infected and will not be able to complete the parasite cycle. Therefore, both risk factors need to be present at the same time to have active transmission of the parasite. When we talk about backyard pigs, what we mean is pigs that at some point during their life had the opportunity to roam free and therefore had the opportunity to have ingested tapeworm eggs. And it's important that we see the whole picture. For example, here we see a backyard pig owned by a smallholder farmer, and the pig is confined in a pen. So we might think, oh well, this pig might not have had the opportunity to access tapeworm eggs. However, as I said before, if we see the whole picture, we might notice, for example, here in this picture on the right-hand side, that there are some small piglets. So what's happening in this case is that the young piglets didn't have too much value, so they were allowed to roam free. And only when the pigs have certain value, then they were confined. You will see that in other areas, for example, might be that the pigs are only confined at certain times during the year, maybe during the harvest or during the planting season or the other way around. So when the pigs, for not having a risk, they would have to be confined during all their life. As for the basic sanitation, the presence of latrines alone doesn't guarantee that there is not a risk factor. because in some cases, for example, the latrines are not all properly constructed like the one that we see in this picture, but sometimes the latrines can be deficient and they allow the pigs to access the waste. In this case, the pigs then can have contact with human feces contaminated and there can be a transmission of the parasite. Also, it's important that the latrines are used by all the family at all times, not only during the day, but also at night, or not only when they are near the house and working in the fields. Many of you might be thinking, wow, these details about the backyard pigs and the latrines might not be easily available. And yes, that's true, and we acknowledge that. But it's important that you keep that in mind, just in case you come across those details. And even if not in first instance, later on when there's a visit to the field and when we're confirming the active transmission at field level. So how can we obtain the information that we want about the different diseases and the key risk factors? We can use different sources of information. For example, for all the diseases and all the risk factors, we can look at the reports of the Ministry of Health, we can use the reports from the Ministry of Livestock or equivalent. We can look at scientific publications, not only the ones that are peer-reviewed or published in international journals, but also the ones that are published locally or part of the grey literature. We can look at PhD and MSc thesis, and we can look at NGO reports or reports from other organizations. Additionally, for example, when we look at data from the disease in humans, from Teniasis, we can look if there are parasitology surveys that have been done for other parasites. For example, if a cat has been done for schistosomiasis or for sole-transmitted helminths, they might have recorded the presence of Teniasis. In some cases, maybe local health centers, they have recorded people with tapeworms. For neurocysticercosis, we can also look at the proxy, epilepsy, and for that we can look at referral hospitals, local hospitals, and health centers because they might know where the patients are coming from. For disease in pigs, for porcine cysticercosis, the veterinary services of the country or of the province, they might have that information. Also, slaughterhouses or local butchers, markets, street vendors, sometimes they know where they have seen the disease. As for the risk factor, the areas where there are backyard pigs, that information can be obtained from the Ministry of Livestock or the veterinary services, and sometimes veterinary and agricultural colleges or research institutes might have access to that type of information. As for areas where open defecation, where there's absent or insufficient basic sanitation, the WASH programs of the Ministry of Infrastructure might have access to that information. So as you can see, there are many potential sources of information. Some might be available or some not. But this list is not inclusive and might be that other sources are available or more appropriate in the areas that you are working. So please don't be limited by this list and be creative in thinking where can you get that information. So who can collect the information? What are the characteristics of a person who can conduct this work? Well, we need is someone who has a basic understanding of biology and the disease cycle, as we have been discussing until now. And very importantly, someone who is really proactive to approach to information search and that will ask guidance if needed. This could be done, for example, by a recent graduate or advanced student on medicine, public health, veterinary, One Health, or related discipline. And it can also be done as a team. For example, one member focusing on the human data and the other member focusing on the animal data. And now let's look at the second step. So once we have collected the information, how can we organize that information? A risk classification tool has been created based on Excel, and that's a tool that you will be able to use for your own mapping. When you open the Excel document, you will land in a page that looks like this, and it's called Intro for Introduction. The top of the page contains the background and a summary of the mapping process. The middle section are the instructions on how to fill and how to use this Excel tool. The Excel document has cells shaded in 3 colors. White means that the cells are not protected, so you can enter the values that have been requested. Orange means that there is a drop-down menu. That means that when you click on the cell, a list will appear and you can select one of the values from that list. And blue means that the cells contain formulas, so they are protected and there's no need to enter data. The bottom of the page has a table to enter the country data. We have several rows. First is country. Second is year, and that's the year that you are entering the data. And then we have the number of administrative units at the lower level that you want to map. And what does it mean how many administrative units at the lower level you want to map? Let's see this with some examples. It will be easier to explain. So for example, if we have a country with 5 provinces and it's decided to map all the provinces at province level, the number of administrative units is 5. If it was decided to map only one province, and I'm using province but can be region, state, depends on what you use in your country, with 10 districts, and we want to map all the districts in that province, then the number of administrative units will be 10. If it was decided to map the districts in 3 provinces, it would be the sum of the districts in those provinces. So for example, if province A has 5 districts, province B has 2 districts, and province C has 10 districts, the total of administrative units will be 17. And this number of administrative units at the lower level is important because this number is used to generate the rows in the form to enter the data. And going back to the intro page to the country data table, the last 2 rows to complete are the name of the person filling the mapping tool and the date of the report. Once the country data has been completed, then you need to click on the button called Generate Form that is in the bottom right-hand corner of the page. Once you click on Generate Form, 2 more pages will appear in the Excel document. One is called Mapping and the other one is called Criteria Info. You will automatically be redirected to the mapping page. So this is how the mapping page looks like. You will have the header already completed with the information that you enter in the first page. You will have the year of the data that has been entered, the name of the country or region, the name of the person who filled the report, and the date the report has been completed. The number of rows that you will have are the number of administrative levels at the lower level that you enter in the previous page. In this example, we have 10 administrative levels. Regarding the columns, columns A and columns B correspond to the names of the administrative units. Columns C to H correspond to the diseases and risk factors associated with Taenia solium. So for the diseases, we have porcine cysticercosis, Taniasis by Taenia solium, and Taniasis. The difference is that in Taniasis by Taenia solium, the species of Taenia has been confirmed, so we know that there is Taenia solium, while here in Taniasis, the species of Taenia has not been confirmed. And the last disease is neurocysticercosis. For the risk factors, we have open defecation, when open defecation is common or is practiced in the area, and backyard pigs, when backyard pigs are common, when we have free roaming pigs in the area. Then the other columns, we have column I, that is the risk level, and then we have another column for notes and comments. Now we need to start filling this mapping page. First, what we need to do is to fill the name of the administrative levels in columns A and B. And you can use the administrative levels that are more appropriate for the mapping that you want to do. In this case, we are using province and district, but you could choose district or subdistrict or whatever is more appropriate for what you need. Next is based on the information collected on step 1 for each administrative level and for each disease or risk factor. You can select from the drop-down menu, that's the list that it appears when you click in one of the orange cells, one of the 3 following options. First is yes, if the disease or risk factor has been recently confirmed. And recent has been defined within the last 5 years. However, if you think that the conditions haven't changed in the area, you can consider a longer period of time. This is really a subjective definition, and this can be changed or adapted depending on the local circumstances. The other options on the drop-down menu are no, if the disease or risk factors are not present, or unknown. Or you can also leave the cells blank. Some considerations for when you are filling the mapping page. First, it's very important that porcine cysticercosis is in autochthonous pigs. That's local pigs that have been born and reared in the area. Because if, for example, the pigs were born in another area and they were just brought in this area for fattening, they might have acquired the disease somewhere else. So it's important that the porcine cysticercosis is identified in local pigs. Second, sometimes there might be evidence of epilepsy, but not specifically of neurocysticercosis. That might be because neurocysticercosis required some very specific diagnostics that might not be available in the area. Therefore, if there's epilepsy in the area and the risk factors are present, you could consider enter yes for neurocysticercosis. You can use column J to enter your own comments or your own notes, for example, the source of information or any other information you might think relevant. So now that we have collected and organized information, let's look at how we do the risk analysis and prioritization. Once the presence of disease or risk factors has been completed, then the risk can be assessed. To facilitate the assessment, a classification from 1 to 6 has been developed. 1 to 2 are high risk. That is when there is evidence or high likelihood that there is an active transmission of the parasite. Levels 3 and 4 are moderate risk. That is when there is an indication or potential for active transmission of the parasite. And levels 5 and 6 are a low risk. That's where the active transmission of the parasite may or may not be present. And how do we define the risk? That's where this Excel tool is really very helpful. We need to click on define risk level, that is this button on the top of the mapping page. And then the risk level in column I will be automatically filled, including the colors. If there is not sufficient information to classify the risk, instead of a number, NS will appear. If you would like to clear the risk level, you can click on Clear Risk Level and all the risk classification will be deleted. But note that all the comments will also be deleted. It is possible to define risk level and clear risk level multiple times. If you want to update the risk classification, for example, because more information is now available, there's no need to clear the risk classification first. You can simply click on Define Risk Level again, and the risk will be updated with the new information, and all your comments will be maintained. Once the risk has been assessed, then you can sort out the administrative levels by risk by clicking on sort by risk. And then all the administrative levels will be sorted in order of risk from 1 to 6. Note that within each category there is no prioritization. Alternatively, you can sort out your data alphabetically by clicking on Sort Alphabetically. Once you have sorted the data by risk or alphabetically, it's not possible to sort out the data as you originally entered it unless you did it alphabetically. However, you can change between sort by risk or sort alphabetically multiple times. You can save the document by clicking on the button Save in Excel in your preferred location. The file will automatically be named using the information you entered in the intro page. You can also now print the mapping table using the usual Excel menu. So in summary, for steps 2 and 3, we are going to use this Excel mapping tool. So we enter the country data in the first page. Then we enter the disease and risk factor information in the mapping page. We define the risk level. We sort as per our preference, and then we can save and print if needed. Now, some of you might be wondering, how is the risk assigned? How is the risk classified? Well, this is done by using a risk criteria table. And what is a risk criteria table? It's a table that defines an overall risk level for different combinations of diseases and risk factors. This is the risk criteria table that the mapping tool uses. It has various columns corresponding to the diseases and the risk factors and shows different combinations. Yes, when they are present, then uses this symbol to represent that might be present, yes or no, the classification will not change, or unknown. And how does this table work? Let's see some examples. Here in the first row, we have porcine cysticercosis in local pigs. Then, independently, if we have been able to confirm the presence of other diseases or not, the risk level is very high. It's classified as level 1. If we have Teniasis by Taenia solium and we have one of the risk factors, then also the risk level is classified as high. However, if we only have Taenia solium, but we don't know about the other diseases or the risk factors, then the risk is lower, because Teniasis could have been acquired somewhere else. However, as soon as some of the risk factors are confirmed when there is Taenia solium, immediately the risk level increases. Here, for example, in this row, we have Teniasis. The species has not been confirmed, and there's open defecation. Then the risk level is lower because it could be Taenia saginata. In the row below, here we have open defecation and we have backyard pig commons. They are pig roaming free. But we don't know anything about the presence of the other diseases. So that might be the Taenia solium may or might not be present. So then the risk level is lower. But as soon as some of these diseases is confirmed, then the level of risk increases. So this is how the table works. This is how the classification is done. But you don't need to worry because the mapping tool does this for you. This risk criteria table is the third page of the mapping tool, and it is provided for information. So for example, you say, oh, why is this area classified at this level? Or you want to know the priorities within each level, then you can consult this risk criteria table. So why use a risk criteria table? Well, first, we acknowledge that we are working with a neglected zoonotic disease and the information will be very scarce and we will have to make assumptions. Therefore, it's easier to have some flexibility and we hope that this risk criteria table provides that flexibility that is needed. We also contemplated created indices or algorithms, but because there's very limited information and many assumptions, then we thought that that will add to the complexity without providing additional value. So that this was a compromise of trying to get a process that was simple, provide flexibility, but it was based in sound technical knowledge. Once the administrative units have been classified in the different risk levels, you might choose to represent the classification in a map. You will have to create your own map. The tool does not provide the map. You can use any editable map and then use the colors to represent the different levels of risk as we have done in this example. So this is great. At this point, now we already have a preliminary map. And remember that you can do the mapping at different administrative levels. In some instances, you might want to start at country level to identify provinces or regions, and then repeat the exercise within these provinces to identify districts, for example. Or you might want to do the mapping at district level and then repeat it at municipality level. The important thing is that this is a very focal disease, so we really need to identify the communities where there is active transmission. You can also use the risk criteria table to decide the risk, for example, at the village level. So it all depends on the objective that you set up when you were doing the mapping. And now we have reached the last mapping step, that is confirming the endemicity. Confirmation of endemic areas. If the data compiled for a specific area is recent and conclusive, then there might not be a need to confirm the endemicity. However, if that is not the case, then endemicity needs to be confirmed before starting a public health program. The details on the current available tests for Taenia solium and the suggested thresholds to trigger a public health program are available on the document Taenia solium, Use of Existing Diagnostic Tools in Public Health Programs. That is the report of a virtual meeting of experts held in May 2022. This report is available on the WHO website in the link shown here, but we're going to see now some of the key conclusions. The key conclusions are: first, the current available diagnostic tests are not well suited for use in public health programs. That's because most of the tests are not commercially available, or are only available for research use, or are not affordable to programs in low and middle income countries. Many of the tests are also not adequate in terms of sensitivity and/or species specificity. Currently, there are limited diagnostic options for mapping and monitoring, namely, for the diagnostic of teniasis in humans, microscopy techniques are the ones that are widely available, but they are not sensitive and they are not species specific. That means that if a positive sample is identified, then it should be followed by Taenia species confirmation. And this can be done by purging, that's treating the Taenia positive persons to recover the worms and do parasite identification, or by molecular methods. For the diagnostic of porcine cysticercosis, which should always be conducted in local bone and rear pigs, we have the tongue palpation and the enhanced meat inspection. The tongue palpation should be conducted in pigs over 4 months of age to provide enough time for the cysts to be developed so they can be identified. This technique has low sensitivity, especially in animals with light infections. However, when it's conducted by trained staff, is high specific. The enhanced meat inspection meets the incision of the Taenia solium preferred locations. That's the masseter muscles, the triceps, the tongue, the heart, and the diaphragm. This technique has a low sensitivity, but substantially higher than tongue palpation, especially in animals with light infections. It is also highly specific when it's done by trained staff. It's important to note that serology is currently not considered an appropriate choice for porcine cysticercosis due to the concerns with the specificity of the available test. Other conclusions reached by the experts are all of the available options have important limitations regarding sensitivity, so it's essential that an adequate sample size is used in the context of a programmatic survey. And given the low sensitivity of the available tests, even a weak signal should warrant a public health response, either in terms of treatment or further investigation. Therefore, the suggested prevalence threshold to start a program is 0.5% in teniasis in humans using microscopy, or 2% in pigs using tongue palpation or meat inspection. The group of experts suggested a flow for confirmation of endemicity in an area that would trigger a public health program. The starting point should be the suspicion of a disease caused by Taenia solium or the presence of both key risk factors, that's roaming pigs and deficient sanitation. The flow in the next slide presents two suggested options, although these are not the only options and they are not meant to be mutually exclusive. The thresholds suggested are intended to be conservative and reflect the low sensitivity of the current diagnostic approaches. They will be reviewed as more evidence is gathered. A survey using either option should be sufficiently powered to detect a low prevalence of infection and should use purposive sampling among high-risk populations. For more details on the sample size and other considerations for mapping surveys, please refer to the report on monitoring and evaluation of Taenia solium control programs. This is the suggested flow to trigger a control program for Taenia solium. The starting point is always the suspicion of disease caused by Taenia solium in the area or the presence of both key risk factors simultaneously, that's roaming pigs and deficient sanitation. As we mentioned previously, we can conduct the diagnostic in pigs or in humans. Either option can be used and they are not mutually exclusive. In pigs, we can conduct the tongue palpation in pigs over 4 months of age or the meat inspection, always in locally born and reared pigs. If the prevalence of tongue palpation or meat inspection is above 2% and both key risk factors are present, then it's suggested to start a public health program. If the prevalence of the tongue palpation is between 1 and 2%, then it's suggested to conduct meat inspection, to check the human data, or to repeat the monitoring 6 months later. If the prevalence of tongue palpation is below 1% and meat inspection is below 2%, then it's suggested to check the human data or to repeat the monitoring 12 months later. This interval between 6 and 12 months later is to allow a new cohort of pigs. If the pigs are negative, then we can always reevaluate 12 months later or look into the humans. For the diagnostic in humans, we can use the microscopy or the coproantigen if it was available, always in a survey powered to detect a low prevalence of infection and using purposive sampling. If the microscopy is positive and we are able to confirm Taenia solium in more than 0.5% of the samples and both key risk factors are present, then it's suggested to start a public health program. If the key risk factors are not present, then it's suggested to treat individuals because that might mean that teniasis have been acquired somewhere else. If Taenia solium is confirmed in less than 0.5% of the samples, then it's suggested to treat the individuals or to check on the pigs. If Taenia solium has not been confirmed and it's another species of Taenia, then it's suggested to treat the individuals. If there's no capacity to confirm Taenia solium, then it's suggested to treat the individuals and to check on the pigs for the presence of porcine cysticercosis. If microscopy is negative, but we still have a suspicion that Taenia solium is present in the area, we can always check the pigs. And with this, we have concluded the last step of mapping. As you can see, Mapping is not difficult, but it does require time and patience to search for the information. So in summary, we have spoken about the 4 steps. First, that it's collecting the information about the diseases and the risk factors in a very dynamic and proactive way. Second, it's organizing the information and classifying the areas by risk. And this can be done using the risk classification tool, that Excel tool that has been developed and that you can use in your own areas in a very simple way. Using the tool, you can classify the areas by level of risk, and then if you want, you can choose to represent that risk in a map. And lastly, the last step, for the areas where the information is not recent or is not conclusive, then you will need to confirm the endemicity. However, this is not the end. It is very likely that the information collected is limited. Therefore, some areas might not have been properly classified. So what should be the next steps? We need to continue to gather information. For example, we need to confirm the species of Taenia present in the area if it was not confirmed before. We need to try to confirm the presence of risk factors. We might visit the area or we might contact local people. We might set up surveys if necessary. And we need to prioritize the areas. For example, areas with risk level 2, so it's very likely that the disease is there, or areas that are surrounded by areas of high risk. For example, looking at the map, we see that this area B2, that there's insufficient information, is surrounded by areas where the infection is very likely to be active. Therefore, that's an area that should be prioritized. Also, remember that every time that more information is collected, the risk classification can be updated. But most importantly, the next step is to start control programs in the communities where there is active transmission of the parasite. That's where there is high risk, the communities at level 1, where there is evidence of the parasite transmission. Remember that Taenia soliums affect the poorest and more marginalized communities, and therefore a public health program for the control of the disease will be needed. As we said, we know that there is very limited information on Taenia solium, so this mapping protocol has been developed to provide guidance in the easiest possible way and keeping in mind those limitations. However, we want to continue to improve the protocol with your feedback and suggestions. So please send your suggestions to the Neglected Diseases team and to Dr. Bernadette Abela Reader at the emails provided. So thank you very much for your attention and your interest in this mapping protocol, and we wish you all the best in your job.